Hello there. This video is meant to be just a quick introduction to the physical look and feel of a StepScope. This is our cute little 18 picosecond edge instrument, TDR instrument, used to study signal integrity and other performance issues of traces and cables. The side of the unit here, we see a HDMI port. Each instrument has a full Linux load, and you can attach a keyboard and mouse and drive them right from the browser in Linux, or most customers simply connect to the Ethernet port and talk to the instruments through their web browsers. It will run on any popular web browser that's out there. On the back, we see the Ethernet, the USB. We have an ID button, which is used to help you identify the IP address of your device on your local network. We've got 12-volt DC on-off switch, power indicator, the all-important ground strap so that you can connect all your equipment to a common ground. On the other side, a fan. The instrument draws about 1 amp, 12 watts, and very quiet running instrument. On the front here, you see our performance and other connections. For example, these two are 2.92 millimeter connectors, and that's for the high-speed TDR signals. The trigger output signal, which is used to synchronize multiple StepScopes in case you're doing, for example, S21 measurements or crosstalk types of measurements. We also have 2 DC control voltages. These are simply voltages that you can use in a test setup. For example, if you have to provide a bias or want to sweep some voltage while you're measuring something else, they're just handy to have. LED lights, one that shows when it's booted and ready to run, and then the other, the pulsar light, which tells it when this pulsar is pulsing. For example, when you're doing S21 measurements, insertion loss, you would have a separate pulsar pulsing into one of the analyzers being used as a sampler. Each StepScope has the ability to be either or both a sampler and a pulsar. On the bottom, we have access to the SD card if you should ever need to get to that. That's more a precaution. But it's very lightweight. It weighs in around, sorry, it measures in around, what do we have, 4 inches by 2 1/4, 2.5 inches by, let's say, say under 6 inches. So very easy to bring onto your benchtop and to help you get your work done. Now, we talked about doing S21 measurements where you have 2 StepScopes. One would pulse into the other, and in fact you can then through the interface tell it which direction if you want to do an S21 or an S12. For customers who are only interested in, say, an S21 and trying to also be conscious of cost, we also have a remote pulsar device. This remote pulsar, for example, will connect to the back through a cable here to the back of the StepScope, and then it will generate pulses synchronized to that same trigger. So you would connect the trigger of the 2 instruments together here to there, and then you'd get your pulses from this device, send it through your device under test and back into the StepScope. That gives us a very high performance edge out of this device for measuring insertion loss. You can look at that in either TDT, a time domain version, or with the S parameter option you can look at that as insertion loss in the frequency domain. So that's just a quick introduction to the size and shape of the instrument, so that you can get a feel for sort of what it looks like and how big it is.